So I've decided not to combine chapter 6 and 7 into one, even though it's short, but we'll just start with chapter 6, which is, overview of methods of data collection. Okay, so before going to this main question, I want to touch on something very important, which is bias. Okay, so the first point here being, if you collect your data badly, you can't do anything with it. There's no fix for collecting data badly. Okay, so if the data collection itself isn't good, then there's nothing that can be done with that data. So there's this saying, garbage in, garbage out. Okay, so don't give it garbage. Okay, so that's the first thing related to bias, and the second thing we'll get to in just a moment. Okay, okay, so there's that. Actually, that was tip number 1. I'll just leave it there. This is tip number 1. Okay. Okay. Moving on to the question, main question. What does population mean? What does this word population mean? Okay. So when you're going with in the entire topic of experiments, this word population comes up a lot, right? And what does it mean? Well, if you think that population means everyone in a country or in the nation or in the world, you're wrong. Okay, population, it depends on the context, really. Say I wanted to find out the average class size at my school. Okay, well then the population is everyone, is all the classes. Sorry, it's all the class sizes in my school, right? So it's not all the class sizes in every school across every district across the country or something, right? It's just you must read the question first before you find, and then establish what exactly your population is. Okay, so you need to know what the population is. It's not simply the entire world or how many people there are or something like that. Okay, so now that we've established what a population is, now we get to the first point, which is census. And a census is basically saying, well, I'm just going to go through every single person or every single thing in that population, and then I'm going to get my data that way. So for example, if my question was, what is the average class size at my school, right? Then I would go and I would find out the class size of each school, and then I would take the average. Because it's a small enough, the population is small enough. So you'd only do a census if population is small. Okay. You can do it if it is big. There are, but then annual census for countries, for example, is only done every 10 years or something, because these things are expensive, right? So on the topic of expensiveness, what they came up with then is a sample survey. Sample survey. Okay, so sample survey, like the name suggests, you take samples and then you ask those people. Now, getting back to the second topic of bias first, because this is incredibly important. A sample is biased if, I will write this down in red, if sample doesn't represent entire, that's an R, population, then it's biased. Okay? And if it does not represent an entire population, it's biased and you can't do anything with it, garbage. Okay? So how do you avoid bias in a sample? Well, you incorporate randomness. Switch back. So you incorporate randomness, okay? So what does that mean? Well, incorporating randomness means that instead, okay, say you have, I don't know, class sizes at your school. So say you have class sizes at your school, right? So you would incorporate randomness by picking out random classes. Okay, we'll get into the topic of randomization is covered. I think it's covered a lot in chapter 7, so we'll get to it then. But yeah, you can't just say, okay, well, I'm going to go to the first 10 classrooms in my school and I'm going to see the average class size there, because it might not represent, maybe the first 10 classrooms are unusually big, okay? So you don't know anything there, and you must have randomness to combat bias, okay? And that is tip number 2. And tip 3 is, what is it? It's the size of the sample matters, but not the actual, not the size of the population, right? So if I pick 500 different people randomly from a sample, from a population of 1,000 people, that's just as good as having a sample size of 500 for 1,000,000 people. Because again, I'm picking them randomly, so I'm representing the entire population, no matter how small or big that is. So only sample size matters. Okay, so that is tip 3. Cool. Yeah, that's about it. And okay, now getting on to experiments. Okay, so an experiment is, well, you can describe it as you're deliberately doing something to someone or something, and then you're measuring the effects. You're measuring what happens after that. Okay, so that the keyword is important. You're doing something, doing something. If you're not doing something, then it's an observational study. Okay, so you must do something. Okay, and this is tip number 4, which is very important. Experiments need not have a control group. So again, a control is basically that, so how a control works as in, you would give a treatment to someone else, but you wouldn't give a treatment to another group or somebody else. And then you would measure, is that treatment really effective? But if they ask you, so this is the problem with, so the questions will be like, is this an experiment? And if it doesn't have a control group, that does not make an experiment. It's still an experiment. If you're doing something to someone, it's still an experiment. Okay? So don't be confused by this. And some more points to add to this is, they don't care if it's badly conducted. They don't care if the experiment is badly conducted. They're not asking you to establish causation. They're just asking you, well, is this an experiment? Right? You don't care at this point, specifically at this chapter, you don't care if the experiment is badly conducted, you don't have a control group, you don't have multiple treatment groups, whatever. And you don't even care about ethics. None of that matters. This is, the question is very simple. Is this an experiment? Okay? And I got confused on this a lot because I was thinking, well, it's not a proper experiment, but then I realized they're not asking you if it's proper or improper. They just want to know if it is an experiment. Okay? So that's about experiments. Let's see. Okay, and finally we get the observational studies, which is, like I said, you don't do anything to someone. So in an observational study, you're measuring, you're standing there and you're not intervening, and you're just measuring the results of something. So maybe you're measuring how much everyone smokes in a day, or how much a certain group of people smoke in a day. You're not telling them what to do. You're just observing. Okay, and yes. So there's a problem with observational studies called confounding with variables, but confounding is actually described in chapter 7. So when I get to that, I will touch back on this question. Okay, but this is tip number 4, I suppose. Doing something is what constitutes an experiment, and not doing anything and just standing there is an observational study. Okay, I think that is it in this chapter. Yes, this is what I got confused about mostly, was that they don't need to have a control group, or it doesn't matter for, if the question is specifically, is this an experiment? Well, it doesn't matter. Okay? It doesn't matter if it's badly conducted, ethically it's bad, whatever. Okay? Yeah, that is it, and we'll see you in chapter, what is it, 7?